Okay, way off. Top of page 8.
It happens sometimes.
So, what is a piecewise function? That. Yes. An easy problem. It does look like this. When you know what you're doing. So a piecewise function are a couple of equations grouped together as one function. And you usually have restraints, restrictions, can even be thought of as a domain. But you literally have a piece of the entire equation. So instead of having the entire parabola, we have a piece of the parabola when x is less than or equal to 1 or when x is greater than 1. So you have two different parabolas being graphed, but you only have a piece of them. And then it kind of makes its own function. It still is a function, so we would have to make sure that it passes the vertical line test because it is a piecewise function. So it says to evaluate the given function at the following values. The first one says f of -2. How do you evaluate the function at the given value? Dylan.
Plug -2 in for the x's and see if they match the restraints.
Plug -2 in for which x's?
The x's on the left.
X is on the left, not the x's on the left. Emma.
You see where the restraints fall and like -2 falls lower than 1, so you plug it into the top equation.
So you're going to actually start with the restraints, constrictions, whatever you want to call them, restrictions, constraints. But you want to actually start with them first before you plug it in. Because once you plug it in, your answer is the y value. But we need to decide which equation to plug it into based off of what x value you're given. So we are given -2. It fits in with the first restriction. So I would use the first equation for all of my values where x is less than or equal to 1. Because that piece of the graph, wherever it happens to be, only has values for the 1. So if I plug a 1 here, it's going to give us a 3. So it looks something like this. The rest of the values don't exist. So I can't find a value if it doesn't exist on that piece of the graph. So because x is -2 and s applies to all of my x values being less than or equal to 1, we would use the equation and plug in -2 squared and then plus 2. So the equation we're using is x squared plus 2. Or the function, the piece that you're using is x squared plus 2. So you're picking the piece based off of the restriction that you're given. So you're actually starting with those first. So Emma, -2 squared plus 2 is 6. So the answer you're getting out is the y value, which is why you can't compare which one it works with then, because those are y's, and the restriction is on the x. So Carrie, letter B says f of 1. Which equation would you pick for f of 1?
X squared plus 2.
Yeah, we'd use that first one again. Because, again, y is equal to 1. Or, sorry, 1 is equal to 1. 1 is less than or equal. So it works for that one. And Carrie, when you plug in 1 squared plus 2, you get
3.
Yeah, so f of 1 equals 3. So you're choosing the equation, one equation. You're not plugging it into both. You're picking a piece because of the x value. The last one, Colin says f of 2. So the equation we would use would be?
2x squared plus 2.
Right. And again, now x is bigger than 1. 2 is greater than 1. So if we plug in a 2, what do you get, Colin? You get 10. So piecewise functions, you pick a piece, one piece, because if you're using 2, then it's not a function. Because then I have 1x but 2 y values, and that means it's not a function if I have 1x but 2 different y's. Each x has to have 1 y. So I'm using the equation based off of the x value. Questions? So on Friday, the very end of the video, kind of squeezed in the domain and range. I really was planning on being here on Friday, but I was a sick kid, so she wanted her mom to stay home. I was going to send her to the neighbors. Be like, you can just sleep on their couch. She didn't like that idea very much. I caved, being the mom I am. So you did number 8. Yes. And then there should have been, there it goes. In finding the domain, there's really 2 things algebraically that we're going to do talking about domain. So the first thing is when the denominator cannot equal 0. And the second one is when you have a square root, the square root must be greater than or equal to 0. Those are pretty much the only restrictions on domain. So underneath, it says domain excludes values that, and there are just 2 exclusions. Everything else works. So it excludes values that make the denominator 0. So any number that makes the denominator 0 has to be excluded from the domain. That means it can't be in it. Any other number works except those numbers that make the denominator 0. And then the other exclusion would be the values that make the radical negative. So the denominator can't be 0. The square root cannot be negative. So it has to be greater than or equal to 0. Because if it can't be negative, the only option would be for it to be greater than or equal to 0. It's allowed to equal 0. So we're going to go through 2 more domain problems. And again, just looking at domain, not talking about range. Domain you can do algebraically without relying on a graph. So the first one we have here is a equals pi r squared. What is a equals pi r squared? What's that represent? A circle. So that's the area of a circle. And we want to find the domain, which in this case would be thinking about the r, so the radius. What kind of restrictions would you have on the radius of a circle? So we want to give the domain or the radius of the circle. So what would the domain be? Josh?
Be greater than or equal to 0.
Yeah, why would it be greater than or equal to 0? Right.
I just thought because there's no denominator showing.
Okay.
Can't be negative for 0.
Alright, so you said no denominator showing. Emma, what do you think?
You can't have a negative radius.
Can't have a negative radius. Why can't you have a negative radius? It's a circle. Can it be 0? If it was 0, would you have a circle? No. So actually, our radius has to be greater than 0. So this isn't in one of the restrictions because this is an actual object. And when you have an actual shape or an object, you have to think that that shape has to exist, and it only exists when it's positive or bigger than 0. So how do I write that as an interval for the domain? So if we have up here r is greater than 0, but we need to write it in interval notation. How do you write interval notation saying r is greater than 0? So if you need to, draw yourself a little number line, get a picture drawn. Here's 0, greater than 0. I now need to write that in interval notation. Sometimes a picture visually helps write something in interval notation. Josh, what would it be?
Comma 0, positive infinity.
Yeah, so 0 to positive infinity, and what kind of symbols go around them? Parentheses. Nice job. So starts at 0, but it can't be 0. It could be 0.000001. As long as that number is tiny, a circle still exists, and then it goes up to positive infinity. Questions? Okay, so any shape has to be positive, and it has to be bigger than 0. So finding the area, the volume, the perimeter, any of those, the domain would have to be from 0 to infinity. Letter B kind of uses both of the exclusions that we just stated above. So we said the denominator can't be 0, and the radical has to be greater than or equal to 0. So there are 2 pieces here, so let's talk about the bottom piece. Brenton, if we have s minus 4 on the bottom, what does that mean?
It means that s cannot be 4.
Right, s cannot be 4. So I'm just going to make some notations underneath here because this can't equal 0. And Brenton, the square root on the top means that
S cannot be 0.
so it can't be negative. So that means it has to be
Greater than 0.
greater than 0, or it's allowed to equal 0. So that means it could be greater than or equal to 0. Because can you take the square root of 0? Yes, you're allowed to take the square root of 0. So if you solve that little equation, Brenton, you would get S is greater than or equal to. How would you solve that equation?
We just square.
Okay, square both sides. So now S minus 1 greater than or equal to 0. X is greater than or equal to 1. So that's using both restrictions or exclusions that we were given. So the denominator cannot equal 0. The radical can't be negative, meaning it has to be greater than or equal to 0. So if I go on a number line and place this information, so I have a 1 and a 4. I'm just now kind of getting a picture so we can write this in interval notation. It can't be 4, so I'm going to cross off 4 because it's not allowed to be 4. And it has to be greater than or equal to 1. So it starts at 1, greater than or equal to means bracket. And then it's allowed to be anything bigger than that, which means anything to the right. Except it has to hop over 4. So it can't be 4, I got that crossed off. It has to be greater than or equal to 1. So it has to start at 1 and then continue to infinity and beyond. So Emma, what does that mean our domain would be then? How would you write this in interval notation, kind of looking at our picture?
Bracket 1, comma, 4 parentheses, union with parentheses 4.
Nice job, Emma. So a bracket with the 1, because it can equal 1, I can take the square root of 0. 1 minus 1 is 0, the square root of 0 is 0. It goes up to 4, but it can't be 4. So when it cannot be something, that's where we place that parenthesis. So the union with means they're both there. It hops over 4, so I have a parenthesis on the other side, and then it goes to positive infinity. So anytime it cannot be a value, that's when you're writing that value twice. So that's the way to show that it like skips over a number. Questions with that? So the last example on the back is a little bit of work with functions. There was only, 3 domain problems last night? Maybe 4. I think there's a lot more today. So, example 8, trying to be politically correct here. A soft drink can. I call it soda because I'm from the Harrisburg area. You all call it pop because you're probably from around here. Does anybody not call it pop? Oh, yay, a couple, more than a couple. Woohoo. Okay. So, soft drink, to make sure we're correct on all sides, has a height to radius ratio of 4. So, we have this soft drink can. My wonderful drawing. And it says it has a height to radius ratio of 4. It wants us to find the volume of the can as a function of r. So before we talk about what the heck that means, how do you find the volume of a can or of a cylinder? Does anybody have their book with them?
Yes.
Ooh, Josh does. If you open up your wonderful book, Josh, just the cover. Yep, open up the cover. And that first page, Josh, is a whole bunch of formulas. And I think even behind that is also a whole bunch of formulas. Actually, is that all trig? Oh, look at all that trig. You might not want to change. Okay, we don't want to look at that page yet. But as soon as you open your book, that cover has all the formulas. Josh, what does it give us for the volume formula?
Pi r squared times h.
How the heck did they get that? Carrie?
It's a bunch of circles stacked on top of each other.
Yeah.
So you take the area of the circle and
So, a cylinder or a soft drink can is literally, as he said, it's a whole bunch of circles stacked on top of each other. So we have pi r squared because that's the circle part, and then we need to know pretty much the height of the can. That's how you get a volume formula because yes, you're using the area of the circle, but then we need to know how high that is to get the volume of all the space in between. So volume is equal to pi r squared times h. So it says for A that we want to find the volume as a function of R. So when it states that, that means the variable that we're using in the equation, the independent variable, is R. That's what that's saying. So we want to write an equation for volume that only has an R in it. And the equation that Josh gave us has an R and an H. So if you go back to the first statement that was given, because it really isn't much information, it says a soft drink can has a height to radius ratio of 4. That's the only piece of information we know. I don't know that the can is 6 inches tall or 7 inches tall or has a radius of 3. It just says that the height to radius ratio is 4. How do you write that as an algebraic statement? Height to radius ratio of 4. So think, how can you write a ratio? Do you have an idea? So she said, would it be 4 to 1? What's 4 to 1?
The height is 4 to the radius of 1.
So she said the height is 4 to a radius of 1. And I'm going to just kind of keep it as the height to radius ratio. A ratio can be written as a fraction algebraically. It can be written with those 2 colons, or it can be written with the word 2. That's how you write a ratio. So you can write it as a fraction, you can write it with colon, those 2 dots, or you can just write it with the word 2. So I'm just translating that information to be an equation. So height to radius ratio is 4. Means the height over the radius together, their value is equal to 4. So how can we try and use that information to write an equation that only contains the variable R? That's what part A is asking for, right? The volume as a function of R. So our goal is to only write it with R. Garrett?
So could, instead of H, could you have 4R?
Yeah, so if you look at this equation, he said you can use H H can be represented as 4R. So in this equation, pi R, and then H, well, I can solve that little ratio and write it in terms of H. So H is equal to 4R. I missed my little square there. So the volume as a function of the radius, Garrett, would then be, write the numbers first.
Wait, what?
So just kind of looking at this, what would the power of R be? Let's start with that.
We just plug in as well.
You're going to keep the R in the question. So you have R squared here, you have another R here. So what's the power of R?
Oh, it would be just R to the third.
Yep, so it's R to the third. And then we have a pi. We didn't do anything with the pi. And we have an R with a 4, so we'll place that 4 in front as we combine the R's together. So instead of height, we're replacing it with 4R because height is equal to 4 times the radius. That's what that means. The height is 4 times the radius. So because we're trying to write a function with respects to R, or as a function of R, we can plug in that information. Josh?
Why wouldn't it be like R equals 4H? Because it said like, if you're thinking of it like, I thought of it as 4 over 1.
Okay.
It's like the height over the ratio, or the radius. Why would it be like 4H equals?
Because a ratio is written as a fraction, so if you would solve for R,
Oh, okay, I see.
R would be equal to,
1. Or I mean 4. I know what you mean.
Okay.
Yes. No, I
Okay.
know what you mean.
okay.
But like, wouldn't it be 4 over 1 though? Like,
I mean, yes, but that doesn't mean that the height is 4 and the radius is
Okay.
1.
alright, I see.
Yeah, so no.
Alright.
It doesn't mean that height always is 4 and the radius is always to 1. It's just the ratio of those values together are going to equal that. So the height can be 12 and the radius can be 3 because that still equals a quantity of 4. Does that make sense?
Yeah, I got it.
Any other questions? Any questions with this equation? So the way we got the equation to use an R was to take that ratio, solve for the H so that we could substitute a value in for H that represented the height. And then we have 4 pi R cubed. So just kind of simplifying, combining some terms there. So part B says write the volume as a function of H. So now we want volume with an H in it instead of volume with the R in it. So the first time we had H equals 4R because we wanted to take out H. So Colin, this time the R would be equal to 1/4 H. Or you could say just H divided by 4. So the height divided by 4 is equal to the radius. So plugging that in, we have pi. The R is 1/4 H. That's squared because it was R squared. And then now we have the H. So we're taking out, this is like substitution. You're taking out the variable you don't want. You're replacing it with a way to represent that variable. Now we need to do a little bit of simplifying. So the part that's squared here, Colin, do you know what 1/4 squared is?
1/16.
Nice job. 1/16. I then have an H squared. So that's what that quantity becomes if I square it, and then we still have the H outside. So Colin, if we just kind of rearrange the terms to make it look nice, what would that become?
1/16 pi H cubed.
Yeah. So when we talk about numbers, 1/16 is a rational number. It goes first. Pi is irrational. It goes second. It's a symbol that represents a number. So we want the actual numerical value to be first, then the symbol, and then the variable H cubed. Questions? They're kind of weird. Especially when you don't really have any numbers given to you besides that the ratio of the two is a 4. Questions on that? So I would like to start the homework with you because I want to go through one of the problems. That's the difference quotient. So I'm going to start at 84. So if you want to take out a piece of paper. If it drives you crazy to start with 84, I apologize. You can put it on the back of your page, I guess, if you want to. Or maybe you're just okay starting at 84 and not starting at 58 like the homework asks. So I want to be able to kind of just work through this problem so that you get a better understanding of the difference quotient. The difference quotient part is that f of x plus h minus f of x all over h. So it's called a difference quotient literally because you have a difference on the top. You're subtracting two problems, two pieces. A quotient because it's in fraction form. Any quotient is also a fraction. That part can change a little bit. It doesn't always have to look like that. Sometimes there's numbers, sometimes there's a c in there instead of an x or instead of an h. So it will tweak a little bit, but the standard form of it is going to be the same. A difference on the top always divided by a single value. How would you start to set up the difference quotient for this problem? So our function is f of x equals x cubed plus x. That's the function part. Emma.
We write the function, but every time we see x, we plug in x plus x.
Right, so we're going to use the function. And as she said, every time you see an x, we're replacing it with x plus h. So we have x cubed. It's still cubed. But the quantity in the parentheses is what replaces x. So in my parentheses is x plus h. And again, it's still a cubed quantity. And then it says plus x. So instead of x, x plus h. So I still have something cubed plus an x. But we're replacing it with those quantities that would be in the parentheses. This is a cubed value. What does it mean if you have x plus h cubed?
It means to split x plus h times x plus h times.
Yeah. So it means that we have to multiply those together 3 times. So see if you can get those to multiply together. FOIL those three parentheses together. So this first part is only looking at the f of x plus h part. We're just doing the algebra for the f of x plus h. So you're multiplying two parts together. Make sure you place them back in parentheses. So x plus h times x plus h. You will get that quantity memorized after you multiply it together enough. Is x squared plus 2xh plus h squared. And then you have to multiply that by x plus h again. So we multiplied the first two together, and now we have to take that product and multiply it with x plus h again. I like distributing backwards. It's up to you how you want to work through that. But I distribute the x to everything in the front, and then I distribute the h to everything in the front. So just kind of check your expanded form. See what you have for that expanded form. So right now I have x cubed plus 2x squared h plus h squared x. And then I have plus x squared h plus 2xh squared plus h cubed. So Hannah, if you combine all those together and simplify it, what does that give you? I know we have an x cubed. What other like terms are up here to combine?
3x squared h.
Good. So x squared h, x squared h.
Plus 2x h squared plus h.
So if you have an h squared and an x and an h squared and an x, and there are two of them, we now have three of them. And then the last one here is the h cubed. So that's that x plus h cubed part. And then next to that, we still have an x and an h. So that's my first step. All of those pieces make a huge expression there. Step 2 says to take f of x and subtract it, or make it all negative. So that means I have to make x cubed plus x become negative. And I'm going to place that with my fraction as well. So now I have negative x cubed and negative x. So the problem is almost done. You just need to kind of go through and get those terms to cancel, pull out the h, factor that h out of the denominator. The goal is to get the denominator to wipe out. Every single time you should have the denominator canceling. Have an awesome day. The other problems that you'll have to do, you got 2 more difference quotients and a lot of domain problems. And I'm going to send the answers through Remind because a lot of them are even solutions.